We are given with a question in which a mass m is placed on a triangular wedge and the whole system is accelerated, and we need to find the value of acceleration when the body m doesn't slide down and the surface is frictionless. If there is friction present, then the block will show a tendency not to come down by sliding through the surface, but here there is no friction, so we need to find the acceleration when the mass doesn't come down, and we are applying the principle of pseudo acceleration and pseudo force to solve this question. And the angle theta is given. These are the options. So let's see how to solve this question. As we are given with a mass m, it will definitely have a weight mg towards the earth, and on resolving mg you will get mg sine theta in this direction and mg cos theta in this direction. Okay, and as the system is being accelerated in this direction, this mass right here will experience a force, a pseudo force ma in the direction opposite to the actual acceleration. So the concept we are using here is the concept of pseudo force. When we are considering the motion of a body, or when we are drawing the free body diagram of a body which is accelerating, or which is in non-inertial frame of reference, which means which is in an accelerating frame of reference, in this case which is the triangular wedge, we need to consider pseudo force, and the pseudo force will act in a direction opposite to the actual force or the actual acceleration of the body. And on resolving this pseudo force, we will get ma cos theta in this direction and ma sin theta along this direction. Okay, so these two forces right here will be balanced by the normal reaction force with which the triangular wedge pushes away the mass m. Okay, so the normal reaction force is balanced by the two forces in this direction, that is mg cos theta and ma sin theta, which means there is no net force along this line. Now there is only a possibility for a net force to be in this line, so let's look at that case also. For the body not to move, there should not be an acceleration. That means the body will not move if net acceleration is equal to 0. That means net force is equal to 0. Here there are two forces acting. One is this towards this left side, and the other one is this force ma cos theta towards this right side. So if the magnitude of these two are same, the body will not move. Okay, so if mg sin theta is equal to ma cos theta, the body will not move. Okay, and we can cancel the m which are present on the both sides of the equation, and on simplification a cos theta is equal to g sin theta, which means that a is equal to g sin theta by cos theta, which is equal to g tan theta. Okay, this means that when the value of acceleration is equal to g times tan theta, then the body will not slide down. If the value of theta is 45, then tan theta would be 1 and the value of acceleration will turn out to g. At a value of acceleration with magnitude g, then the body will not slide down, and as the value of this theta changes, this value of acceleration will also change. So the answer goes to option C, which is equal to g tan theta.